All right, our last topic in our work with linear functions is sort of a modified linear function. We're going to be looking at absolute value functions. And we'll start off with an introduction and then do a couple examples of graphing these guys. So our definition of an absolute value function, it's called a piecewise function because our definition is split into two pieces based on what x is. So if x is greater than or equal to 0, or if x is less than or equal to 0. And you'll see a little overlap there. What if x is equal to 0? Well, both pieces will work if x is equal to 0, and I'll show you that in a second. So if x is positive, greater than or equal to 0, our absolute value function is just the same as y is equal to x. Okay? And then separately, if x is negative, our absolute value function is y is equal to negative x. So let's go ahead and plot those guys. And I'm going to plot it down here in our first example just by graphing points or plotting points. But we'll take a look at how our definition of absolute value relates to that and how we can see a couple different lines being graphed. So let's have us start at -4, and we'll just go up by ones. And I just want you to really think of this as absolute value just strips away any negative signs that we see. Absolute value tells us the distance a number is from 0. Okay? So how far is -4 from 0? It's 4 away. How far is -2? It's 2 away, etc. Okay, so there are our points we can plot. Okay? And let's go ahead and plot them. Just a basic going up by 1 scale here. So we're going to have these 4 points on the left. We have our 0, 0. And then let's connect them. And we'll draw an array here, a half line, and then add an arrow on at the end. Let's see. All right, so trying to make a connection here to what we were talking about at the beginning. Let me fill that in. Okay. So y is equal to x if x is greater than or equal to 0. So that's this piece right here. So x is greater than or equal to 0, and we just have a y equals x line, slope of 1, intercept of 0. And then separately, if x is less than or equal to 0, y is equal to negative x. So we have that line right there. And so you can see that the 0, 0 point falls on both lines. Okay? So our absolute value function is always going to look like some sort of a v. It might be squished or stretched or moved around or maybe even flipped upside down, but it'll always look like some sort of a V type shape. So let's do a little bit more of a complex one right here next. And I want to drop a little information on you and give you a standard form. This isn't our complete standard form, but this is kind of a partial standard form for what we're going to be working with in this unit. Okay, V stands for vertex. And flipping back up to our initial graph, that's the vertex right there. All right. And the coordinates of the vertex are going to be h comma k. And according to this form, x minus h and then an x plus a k. Okay. So as an example that we're going to be looking at here, this means h is 1, and this means k is 2. So our vertex is 1, 2. All right. Later on, maybe even in Algebra 2, we'll look at much more complex versions of the absolute value function where we're flipping them and stretching them and such. But for now, all of our absolute value functions are going to look like just a basic v with each half of the v being either a slope of 1 or -1 with a particular vertex. That's the vertex right there. So let's graph this guy. So over 1 up 2 is our vertex. And then our slope is up 1 over 1, up 1 over 1, up 1 over 1, or up 1 over 1 in the other direction. And we can really just draw in a ray here, and we get our nice absolute value function, and this is 1, 2. Okay, so there's the graph of that function that we were dealt right there. All right, next one, Often you just need to be careful with the negative signs. So I will rewrite this guy in our sort of official standard form, x minus a negative 3 plus a 1. So this is our h value. So h is negative 3, and k is 1. Okay, so let's graph it up. Negative 3 up 1, there's our vertex. Up 1 over 1, up 1 over 1 in both directions. Let's create our v. And looks like we got it right there. So this is our vertex of, let me make that a little better here. Our vertex is negative 3, comma 1. All right, and that's a good place to stop right there.